A 3D printer being monitored by software running on the £85 Dell. No Raspberry Pi, no cloud, no separate device. The Optiplex. Episode 3, Tools Online. An agent connected to language models can reason and hold a conversation. Language models let it think. Tools and services let it act. The services need to exist first. Docker runs applications in containers. A container is a sealed package. The application, its dependencies, its config. Nothing conflicts with anything else on the host. Remove a container and nothing is left behind on the system. 4 layers now. Proxmox at the base, Linux VM inside Proxmox, Docker inside the VM, containers inside Docker. Each layer is independent. A container can crash without touching the VM. That structure keeps the server stable as it grows. Docker is the foundation for everything we are running on this machine. Instead of installing software directly onto the host operating system, Docker packages each service into its own container, a private environment with its own dependencies, libraries, and configuration. If a container breaks, you remove it and start fresh. Nothing touches the host. On Debian, setting up Docker means adding the official Docker repository, importing the GPG key, then running a standard package install. The package pulls in the Docker engine, Container, and the Compose plugin in one go. Once installed, systemctl enabled Docker makes sure it starts automatically on every boot. We also add our user to the Docker group. Without that, every Docker command needs sudo, which gets old fast. Portainer is the answer to managing Docker without living in the terminal. It is a self-hosted tool that runs as its own container, giving you one place to see everything. Running containers, stop containers, images, volumes, and networks all at a glance. Setup is 2 commands. First, create a name volume to store Portainer data, then run the Portainer container. It binds to port 9453, mounts the Docker socket so it can talk to the engine directly, and uses the volume we just created. The restart policy is set to always, so if the machine reboots, Portainer comes straight back up. Open a browser, point it at port 9443, accept the certificate prompt, and set an admin password. From here you can browse every container, check its logs in real time, inspect environment variables, see resource usage, and deploy new stacks without ever opening the terminal. Deploying a new service takes about a minute. Pull up stacks, paste in a Compose file, hit deploy, and Portainer handles the rest. Each container has live logs, a restart button, and a usage graph. If something goes wrong, you can spot it without opening a terminal when checking manually. For a Homelab running multiple services, this is what keeps everything under control. One view for everything. No more remembering which ports are in use, which containers are running, or which volumes were configured months ago. Portainer is a web interface for Docker. Install it as a container, navigate to the server IP in a browser, and the dashboard shows every container running on the machine. Start, stop, restart, pull updates, check logs, all from any device on the network. The first real service, Obico, open source 3D print monitoring. It connects to the printer, streams a camera feed, and runs a computer vision model to detect failures as they happen. A print goes wrong while you are not in the room. Obico catches it. Obico is AI-powered failure detection for 3D printing. The self-hosted version runs the entire AI pipeline on your own hardware, with no cloud subscription and no data leaving your network. Your printers are watched around the clock. It installs as a Docker Compose stack, so with Portainer already running it is straightforward. Clone the Obico repository from GitHub, copy the example config file, and set your machine local IP address as the server URL. Bring the stack up and it pulls 4 services: a web server, a machine learning worker, a cache, and a database. Everything starts together in one command. The AI model watches for print failures in real time. It was trained specifically on 3D printing. It knows what spaghetti looks like, what a layer shift looks like, and what a healthy print looks like. When it detects a problem above its confidence threshold, it pauses the print and sends you an alert. Connecting your printer takes a few minutes. Install the Obico plugin into OctoPrint, point it at your server IP address, and the printer registers itself. From that point, every print streams to the Obico server and is checked by the model. On this Optiplex, the inference runs fast enough to analyze frames regularly and catch problems early. Your printers can run overnight and the server does the watching. Running Obico as a container means the printer is watched around the clock without a dedicated device sitting next to it. Once connected, the dashboard shows the live camera feed, layer count, and failure detection confidence. The server is doing something useful now. As services go onto the server, Hermes gains tools it can call: query printer status, pull a report, trigger an action. The routing logic works the same as model routing. A question arrives, the agent picks the right tool, the tool responds, and Hermes passes the result back. Proxmox snapshots the VM in seconds, installs something that breaks the configuration, rollback, and the machine returns to exactly how it was. One habit worth building: snapshot before every significant change. That single step turns the machine you experiment on into one you trust. Docker installed, Portainer running, Obico live, printer monitored around the clock, snapshot taken. The server has earned its place. Episode 3, done. The service layer is live. One container running, one service doing real work. Home Assistant is next, then more automation, and the connections between services start forming something worth calling a system. A like goes a long way, so please like, comment, share, and subscribe. Be good, and if you cannot be good, be kind. See you next time.